Alright, in this problem we have a spool that has a mass of 100 kilograms and a radius of gyration of 0.3 meters. Okay? If I know the coefficient of static and kinetic friction at point A, I want to figure out what the acceleration of the spool is, the angular acceleration of the spool is, if I pull on a cable wrapped around it as shown with a force of 600 newtons. So I'm going to start by drawing a free body diagram. So I've got my 600 newtons. Put it right there. I've got the weight of the spool acting at the center, and then I've got the normal force and the friction force drawn right there. Okay, so first things first, I'm going to sum the forces in the x direction. So I've got 600 newtons. I've got my friction force, and that equals the mass times the acceleration in the x direction, which is just going to be 100 times ag. In the y direction, I have my normal force and my weight, and then there's no acceleration in the y direction. I sum the moments about g, because I always sum the moments about g. The moments about g, basically the weight and the normal force go right through it, so all I have is the 600 at 250 millimeters away, and a friction force that's 400 millimeters away. And that's going to equal I alpha, where I, due to the radius of gyration, is the mass times the radius of gyration squared times alpha. Okay, so I've got three equations here. Okay, so what I need to do is, I don't know whether this is slipping or if it's rolling. Okay, I'm going to assume that it's rolling, so there is no slipping. Okay, so that means that the acceleration equals r times alpha. Okay. Notice that in this problem they've assumed alpha to be in the negative direction. Okay. So they're assuming alpha is in this direction and acceleration is in that direction. Okay. Which is why the 6 times 25 is positive and the 0.4 times FA is negative, to get it in the same direction so that alpha is positive. So just you're going to want to be careful with how you set up your axes here. Okay, so they're calling basically here clockwise positive, which is opposite how we typically do it. But as long as you're consistent, you're okay. And they do that just so they can keep have this relationship where a positive alpha creates a positive ag. You just want to be careful and know what you're doing when you make that assumption. Okay, so when I do that, basically I can solve for alpha now. Okay, because I can find NA. Okay, I know AG, excuse me. Okay, so between AG and FA, these top two equations, I can solve for alpha as that. Now what I need to do is, using NA and the friction, FA, I want to prove that it actually does not slip. Okay, so I take that normal force times the coefficient of static friction, that equals 192, which is greater than the friction needed to get this thing to roll, which is 24 newtons. So I get 24 newtons. Okay, the maximum is 196, so I clearly am not above that maximum, so my assumption that it does not slip is correct. Therefore, my alpha of 15.6 radians per second squared is correct. So again, just sum the forces in the x and y, sum the moments about g. Okay, make an assumption about your friction, solve, and then prove that the friction is correct.